couldn't have taught it that well. No questions? 0 questions? All happy, content? You sure? I guess I taught it well enough. All right. So let's look at the notes. So we are in H. Okay. What does this even say? This is the same thing we've been working with. So today we're going to look at the rational functions where we have the squared in the denominator. So these are going to look a little tiny bit different, but I think we'll be okay with it. All right, so if I have x squared in the denominator, my vertical asymptote is going to be x equals 0. My horizontal asymptote, and this is where students start getting caught up a little bit. Do you agree that this is x to the 0 right next to it? So the degree on top is less than the degree on bottom. So y equals 0. So my x and y axis are my horizontal and vertical asymptotes. Roots? No. We're not going to have roots because my horizontal asymptote is the x-axis. Y-intercepts? No, because my vertical asymptote is on the y-axis. Now, this is where you have to be careful. You can't just say, oh, I know what the graph is going to look like each and every time. Okay? So I'm not going to do the points below. I'm going to do the points here. So I'm going to go, if I plug 1 in, I'd get 3 over 1 squared, which is 3. So I get 1 comma 3. That should be relatively easy to deal with. Okay, so I'm pretty sure that this graph over here is going to look like this. Okay, then I want to take -1 and plug it in. If I plug -1 in for my x squared, I'm also going to get 3. So this one looks a little bit different. I can't get anything underneath the x-axis. Okay, so it kind of looks like, you know, I don't know, a tree with roots, I guess. So where things get messed up with this is my domain becomes -infinity to my vertical asymptote, and then my vertical asymptote to infinity. But this is where we have to be careful, and it doesn't ask here. I am not. Oh, okay. I'll get this. I'll get this to him.
Okay, it's from.
Okay. So the range on this, being it's not happening underneath, it's going to go from 0 to infinity. So that's where these kind of get different. But you just got to be cautious with these because it's not always going to work exactly that way. It's just you have, pick something on the right side of the vertical asymptote, on the left side, then it's going to indicate what's going to take place with the graph. Did I ask for anything else there? No, we're good. All right, so now let's look at this one. So a couple things I want us to note. We have this negative, so I bet you that negative out front is going to do something with it. My vertical asymptote is, if I have x minus 2 quantity squared equals 0, square root both sides, so my vertical asymptote is x equals 2. So if x equals 2 takes place, I'm pretty sure we'd be safe to say that it's going across the y-axis. And then my degree on top, this is x to the 0, degree on top is less than degree on bottom, so y equals 0 is the horizontal. Remember yesterday we were working when they were both the same, you took the lead coefficients. So roots, not on this one, because my x-axis is an asymptote. The y-intercepts, well, let's think about a y-intercept. If I plug 0 in for x, I'd get 0 minus 2, that's -2. -2 squared is 4. 4 over 4 is 1, but then I have this negative. So 0, -1. Okay, so right now I know that this graph is going to do this. At this point, I need to figure out if it's going to be downstairs on the other one. I don't want to assume that it is. So I'm going to pick the point, say 3, and plug it in. So 3 minus 2 is 1. 1 squared is 1. 4 over 1 is 4. 3 -4. Okay, so this one worked out nicely as well. So that negative out front flipped it over the x-axis. My domain, negative infinity to my vertical asymptote, which is 2 to infinity. And then my range on this one is going to get a little goofy. Anyone want to take a shot at it? Bottom to top. Yeah.
So it would be negative infinity to the bracket, not bracket, parentheses, so, and then a to the 2 to infinity.
Well, the range is going to come up, so it comes up to the horizontal asymptote.
0, so
negative infinity to 0, and that's it. Because it doesn't go above that, so. All right. All right, so let's see here. If I set the denominator equal to 0, so I get this, I take the square root, x is equal to square root of negative 3. My friends, where is square root negative 3? Not here. Vertical asymptote doesn't exist. Does that make sense? Set the bottom equal to 0. It became an unreal number. Being my xy axis, our real number system, and I didn't change it. Can't do that. Horizontal asymptote, this is to the first, this is to the second, so y equals 0. So we have something down here. Now, what in the world does our graph look like? Well, our roots, because my horizontal asymptote is the x-axis, I'd say no. My y-intercept, if I plug 0 in for x, I'm going to get 8 over 3, so 8/3, which is 2 point, somewhere in here, right? Okay. What in the heck does this graph look like? Well, let's pick a couple extra points that we might be able to fathom, and we don't have to go crazy with this. I mean, something that's not going to happen at negative 55,000. That's going to be any different. But I'm going to take, say, negative 1 and just see what happens there. If I take negative 1, plug it in for x, on top I'm going to get 9. On bottom I'm going to get 4. So negative 1 and 2 1/4. Oh, it's like this. Okay. What happens if I plug 1 in? Well, 8 minus 1 is 7 over 4. So 1 comma 7/4. Oh, so this kind of has a strange tradition here. You got a little hump in there. Okay? So my domain is negative to positive infinity because I don't have anything that if I plug in that makes my denominator 0. There's not a vertical asymptote. This is, and I'm not going to test you on this, but the range on this is kind of ridiculous. It looks like I have a maximum value here at what was that? We say that was 8/3. Why is this a square bracket? Because I include that point, that y-intercept. That happens to be our maximum. This is a soft bracket because it's approaching an asymptote. So that's what my range is. Oh my gosh. Aren't you glad I don't have a test on this? There's nothing tough like this on the capstone or the final. The ones on the final are much harder. So, did I get through it? Is that it? Oh, I got this one. Vertical asymptote, I'm going to say no right off the bat. Why can I say that? Yeah, if I did this, x squared equals -2. I get I get a complex number. Horizontal asymptote, degree on top. is less than degree on bottom, so y equals 0. So we get that. Roots, nope. Y-intercept, sure. Let's see what the y-intercept is. If I plug 0 in, 10 times 0 is 0. 0 over 2, 0, 0. Anyone see something wrong with this one? It's not supposed to have an x-intercept. But this is the real perverted thing about this. We'll create these rules in math, except for. Here's an except for. Now, I will tell you, this will be something that you'll see in pre-calc and calc. But this definitely, that point, that is the origin, definitely exists on this graph. Okay? Just by looking at the what we have here, I would say the domain's going to go negative to positive infinity. But here's where we kind of start getting into some trouble. So let's see. I know I have this place for additional points down below, but I like making my t-table over here. Let's see this. Let's plug -1 in, see what we get. I get 10 times -1 is -10 over 3, so -10 thirds. So -1, -3 and a third. Oh, jeez. Now I have this perfect. Okay, what happens if I plug 1 in? If I plug 1 in, I get 10 over 3. I need to investigate this a little further. Let's plug 2 in and see what happens. So I'd get 20 over 6, which is 10 over 3. So at 2, I'm at 3 and a third. At 2, I'm at 3 and a third. Yeah, I did that right. Plug 2 in. 20 over 3. 20, 20 over 6. 10 thirds. What happens if I plug 3 in? If I plug 3 in, I get 30 over 11. 30 over 11 is not quite 3. Oh, geez. This is what this graph looks like. How are we supposed to know that? Well, you have all of next semester to worry about that. That is a wackadoodle looking graph. Now, just because I'm a sick and demented person, we're going to find the range. So this point's the max. This point is the min. So that was at -10 and a third is the minimum value. +10 and a third is the maximum value. That's something that makes you want to go kick a puppy with that kind of question. That's where your fortunate Desmos works really well. And this is where all of life, the universe converges onto itself because, but you said there are no roots. Well, 0, 0 did indeed work. So we do have a root. So it went against everything we know about an asymptote because you have the, well, because of, and really what took place on that one, which is different than the other ones, is I have a monomial with an x. The one before it was a binomial with an x. Before that was just a constant. It didn't have an x. Then we had a constant, and I'm just talking about the numerator. So because we have this denominator or this numerator that has a monomial value in it, that's going to mean something. Okay? How in the world are you supposed to remember that? I don't know. I just don't know. And this one's going to be even worse. The bottom factors to x minus 3 quantity squared. On top, I'm going to make this negative x plus 2. The degree on top is less than the degree on bottom, so I'm good with y equals 0, which is here. Yeah, but Stirrup, the last one crossed. Yeah, this one might cross too. I don't know. Okay, vertical asymptote. If I set the bottom equal to 0, root both sides, x equals 3. So vertical asymptote at x equals 3. Roots. We're not falling for that one again, pal. Okay, y-intercept. I can do the y-intercept pretty easy. Plug 0 in. So I get 2 over 9. Domain, I have no idea yet. Let's fathom some more points. Let's take -1, plug it in. If I plug -1 in, I would get 3 over 1. That's 7. 7. That's 3 over 16. -1, 3/16. Yeah, let's plug 1 in, see what happens. If I plug 1 in, I get 1 over 1 squared. 1 minus 6, that's -5. -5. Or 1/4 is closer down here. Let's plug 2 in. I plug 2 in. 2 minus 2 is 0. Oh, crud. So this one actually looks like this. So far. Plug 4 in, see what I get. If I plug 4 in, 2 minus 4 is -2. 4 squared, 16. 16 minus 24 is -8. So -2/17. Roots. Domain. Oh my goodness. I kid you not. Look at how ugly that graph is. Like, how in the world are you even supposed to know this? And I'm being sarcastic, but I'm also kind of halfway serious on it. It's like all the rules that you learned about asymptotes is now being broken. Well, can we ever cross the vertical asymptote? I bet you at some point you could. Not in these though. That's just silly, just ugly, just crazy. You know, the range on this one, I would say it's -infinity to, I don't know, what's my high point? 3/16? 0. Is 0 at the highest point? 0, 2/9? Yeah, 0, 2/9. That's my highest point. Oh, and it's a square bracket. Okay. Yeah, no. Okay. So, what should we even deal with on homework? You guys want a lot? Yeah, let's do a bunch of these graphs. That'd be so much fun. And then you get here tomorrow going, they're all wrong. Let's see. This was, what did I just teach you? G? H? Was this H that we just did? All right. What do we say we do? 11, H. Let's do 4, 5. We got to give a goofy one. How about 4, 5, and 9? 3 problems where none of the graphs are going to look like what you think they should look like. I would strongly encourage you to, yes, you could try and plot these on your graphing calculator. It might drive you a little nuts. I'd say if you do it on Desmos, you might do a little bit better with it. And you got tons of time to get 3 problems done.